Hello everyone. Today we are going to discuss one problem on torsional shaft. So before proceeding into this problem, so please go through the previous video. So where I have derived the equation for torsion of shaft. So in that I have clearly explained how to derive the torsion equation. T by J is equal to tau by R is equal to G theta by L. And after that we have come across with some of the formula. For example, power. Next one is torsional rigidity and polar section modulus and all those things. So please go through that video. After that, please refer this because various formulas we have come across with that the previous video. Now, in this problem, a solid shaft of 60 diameter runs at 160 RPM. So find the power. So that's the first thing you need to find out the power that the shaft can transmit if the permissible shear stress. Permissible shear stress is maximum shear stress. So 80 Newton per millimeter square. And the maximum torque is likely to exceed, okay? Maximum torque is likely to exceed 30% over the average torque. 30% over the average torque. Also find the angle of twist, theta, in degrees for a length of 8000 mm. So for this, you need to take modulus of rigidity as 80 GPa. So coming to the problem, before solving this, list out the data given. Diameter is 60 mm, N is 160 RPM, tau is equal to 80 Newton per millimeter square, T max is equal to 30% of the average torque. So T max is equal to 30% of average torque. So L is equal to 8000 mm, G is equal to 80 GPa. So that is 80 into 10 to the power of 3 Newton per millimeter square. Now, so to find the power transmitted by the shaft, the formula is P is equal to 2 pi nt by 60. So T we are going to take it as average torque. Now, before that, we are not directly going into this because we need to find out this value, P average. So for that, we have this equation. Okay, so if you have already gone through that previous video, you may have already known how we got this equation. T is equal to pi d q by 16 into tau. So D is 60 mm given in the problem. Just substitute here. So you are going to get the T. So T is equal to 33, 92, 920.1 Newton millimeter because we are getting in Newton millimeter because shear stress that will be in Newton per millimeter square. So from this, we are converting this into Newton meter. Okay. So just multiply by 10 to the power of minus 3. The Newton meter. So here millimeter, millimeter 10 to the power of 3. When you substitute that, it will become meter. So 33, 92, 920.1 will become 3392.92 Newton meter. Now, this torque, if you substitute in that, in this equation, okay, not in this, in this. So what it will become? So T average is equal to T max divided by 0.3. So you know that T max is equal to 0.3 times the T average. So from this, so T average will be equals to T max divided by 0.3. T max is 3392.92 divided by 0.3. So average T average torque is equal to 11,309.73. Now substitute this value here to find the power. So the power will be 1,89,496.34 watt. So 1, 2, 3. So 10 to the power of 3 watt. So a 189.49 into 10 to the power of 3 watt. So 10 to the power of 3 will become kilo. So P is equal to 189.49 kilowatt. That is the answer for this problem. Power P. Next thing is, what the next thing we need to find? We need to find angle of twist. So after finding the power, we are going to find out this angle of twist. So for this, we are going to use this formula. So again, please go through the previous video where we have derived this torsional equation. So T by J is equal to tau by R is equal to G theta by L. So from this, we are going to consider this one, not this. Because here we need to find out the angle of twist, that is nothing but theta. So tau by R is equal to G theta by L. So tau is 80 Newton per millimeter square, R is 30 mm. That will be equals to 80 into 10 to the power of 3 because G is the modulus of rigidity that is given in the problem. 80 into 10 to the power of 3 into theta divided by, so L length is 8000. All these are in mm. Okay. Now from this equation, theta is equal to 0.2667 radian. Convert that into degree. So the final answer, angle of twist will be 15.28 degree. Okay. So from this problem, we have found out what is the power transmitted and angle of twist. So power transmitted, we have used the formula 2 pi nt. Okay, 2 pi nt divided by 60, and angle of twist. So for this formula, you need to go for torsional equation. Okay. So thank you. We will meet in the next class with a new problem.